Our last speaker couldn't be more timely. I'm one of those people that clips things out of the newspaper, and I must have 15 articles on various things related to the South Coast Air Quality Management District over the last several months. Jason is in charge of air quality measurements for the air basin. He oversees a network of over 35 ambient air monitoring stations and is responsible for coordinating field activities of special air monitoring projects focusing on air toxics and local impacts of air pollution. He's got a BS, MS, and PhD in chemistry from UC Irvine. Let me introduce John. All of our speakers' names started with J today. I don't know if that's a total accident, not intentional.
Well, at any rate, it's a great lineup, and it's a great pleasure to be here, and it's an honor to be here at the 5th Annual Climate Change Forum for this organization. And, I have to say that it's great that John took us from Paris to the world in his presentation, and then Josh was able to take us from the world to outer space with the satellite measurements. So it's my job to bring us from outer space back to home. So as being part of the local air quality agency for Southern California, I think that's appropriate. And John had asked me to talk about air quality, but kind of in the context of John and Josh's talk, when we think of air quality, and especially my role in it, which is to measure the air for it, the first question that Josh received about the data kind of connects everything together. Because as John was talking about the targets and the commitments that all the nations are going to make, there is no way other to track that than with measurements. Because ultimately, they have to indicate they're reducing the emissions by X amount. It's the measurements and data that is going to confirm and hold accountable what those nations and the progress of those nations are progressing. And as Josh's talk addresses the first question, the data to us to provide to the modeling, because again, models have to reassess against the measurements in order to reduce their uncertainties. So we know, number one, what the current status is of how we're doing, plus a kind of near future prediction of how things are to become. So when I talk about kind of air quality and the measurements in the first section of the presentation, try to keep it in the context that a lot of what we talk about in air quality can also be applied to greenhouse gases as we move forward. One of the things and kind of the newer and emerging technologies for measurements is that a lot of times these measurements are done by larger organizations, such government organizations to run it. There has been a push now to see, well, what's the air in my community? So there's the emergence of these kind of low-cost sensors. So I'll kind of speak to that on how there's going to be maybe more of this data. So as we talked about that data revolution, this is kind of that next step in that category. And we also, Josh hit a little bit upon remote sensing. I mean, they're able to do it from satellites, kind of give that global perspective, but on a local perspective for us, as we try to maybe hold accountable stationary sources or mobile sources within our local jurisdiction, we have a little bit more of that maybe tower profile, remote sensing, looking at specific areas of emissions. And then, of course, this is a climate change conference, so we'd like to address a little bit about climate change and impacts to Southern California, and kind of what some of the California policies are working towards that. And of course, wrapping it all up together in a very real event that happened recently, we had the natural gas leak that occurred at the Aliso Canyon facility, and kind of our efforts to address that. So that's an aggressive schedule, so I'll talk fast. So in the 1940s, air pollution was a huge problem. I mean, visibility was poor, people were suffering from a lot of respiratory disorders, choking, and not being able to breathe, having to wear something over their mouth so that they can be able to breathe adequately. So, one idea to try to reduce the amount of pollution would be to can it up and sell it as a tourist attraction. Unfortunately, in the 1940s, that didn't quite work out. So instead of that idea, they had to go towards air quality regulation. So air quality in a nutshell is done by 3 different agencies at the 3 different levels. One at the national level, US EPA. They set the national ambient air quality standards for all of the air quality for the nation. They regulate all the kind of interstate sources of pollution, as well as they oversee all the federal greenhouse gas programs. Then we go to California, and as John mentioned in his talk, you notice that California was at the leading edge of a lot of things. They were first to sign up for a lot of these minor group initiatives for greenhouse gases, and I'll talk to a little bit in the presentation about some of the policies that they are doing to address greenhouse gas emissions. But they're responsible for adopting statewide air quality regulation, and they kind of approve the local air agency plans for achieving clean air. And that brings us to kind of local air districts, which is like us, South Coast AQMD, where we monitor air quality. We bring it real to the local stationary sources that are within our jurisdiction. Within our jurisdiction, which covers LA, Orange, San Bernardino, and Riverside, we have 27,000 sources that we do regulate and permit. So we have, instead of the worldwide, we cover 10,000 square miles within our jurisdiction. We cover 17 million people and growing, and it includes a lot of sources of pollution, which affect our quality, but also contribute towards the greenhouse gas inventories. So keeping that in mind, we want to be able to reduce the amount of the pollution, but it also has the benefits of also reducing the amounts that are being contributed by these sources towards climate change. So the air pollutants of interest at the federal level are listed in red. They include particulates, ozone, carbon monoxide, nitrogen dioxide, sulfur dioxide, and lead. And then we also look at, from the air quality perspective, air toxics. And these are compounds that, when exposed to for over long periods of time at certain concentrations, they can lead to carcinogenic effects. And then lastly, we are looking into greenhouse gases. So we do this by having measurements that are being conducted at over 40 stations now. We've recently deployed quite a few more stations to measure the air quality throughout the basin. And these stations range from being on top rooftop buildings. The picture on the right shows a building on top of downtown Los Angeles. We have stations that look like modified shipping containers that are deployed in kind of the outskirt regions of the basin, and we also have it within just kind of different communities. So these stations run what are called continuous analyzers. They measure in real time the amount of air pollution that station is seeing. They provide this information on an hourly basis to our website, so that way it can be publicly accessible. And then there are computer models which kind of transform these pollution concentrations into a air quality index value to kind of generalize it to say, is it good air quality today, moderate, or is it you need to stay inside and watch TV? We also have some other samplers that are not real time, and these collect samples into different media, such as canisters or filters or little cartridges. And these are for more complicated analysis to look for those air toxic components, and then also to get a better chemical profile of filters that would be connected to particulate matter. So those samples are brought back to an in-house laboratory. It's a state-of-the-art chemical laboratory, which we run those samples, and they look for different chemical parameters. And from these chemical parameters, we can then give that information to the modelers, which then can, again, reduce the uncertainty on their forecast for air quality. In addition, the laboratory does analysis on consumer products. There's a lot of consumer products that get kind of a stamp of AQMD approval, that they contain low amounts of chemicals that can cause air pollution. We also process samples from stacks. So when facilities are emitting, you may see sometimes they have these large stacks that could be emitting pollutants. So we actually test what's coming out of those stacks to make sure that they're in compliance to their permit and they're not emitting more than they should. And then we also look at asbestos, and we also do a lot of method development because, again, chemical analysis methods change over time, things get better, and especially not only in the laboratory but also in the field. I mean, as I'll talk to you in the next section, a lot of development is being done to get a lot of the traditional measurements that are done in kind of by the lab rats. I used to be a lab rat, now I'm kind of in the field. So it's kind of like me in a nutshell, where you kind of start off doing some of this more hands-on work that takes a lot of time, and then you can go to the field and then you can get this real-time information. So some of the challenges that we face as a air quality agency are several-fold. First, with regards to the pollutants that I had mentioned earlier, there are 2 pollutants that we are not in attainment for, which means that we're not meeting the air quality standards as set by US EPA. And both of those are ozone and PM2.5. And then, of course, air toxics is a concern. There's still certain stationary sources that are producing chemicals that can impact nearby communities, and we're there to assess that and work with those facilities to reduce the amount of pollution that they emit and impact the communities. And then greenhouse gases, we have several of the staff that are devoted to looking at climate change impacts and working with the state on policies. So some of the objectives from the policy side, and this is looking purely at the ozone and PM2.5. And again, this can be expanded later on as the US develops those greenhouse gas targets, as California develops those greenhouse gas targets. This is kind of a parallel of what may yet to come. So on the graph here, it shows a timeline of when we're supposed to meet certain standards. So there's a certain timeline, and just the take-home message is, over time, those standards get stricter and stricter. So our target to try to meet these goals as new science becomes available, and the new standards are always based upon looking at the most recent available science regarding health studies, and they incorporate that science to then establish these air quality goals. So as the science has become more developed, as they understand more about sensitive populations, a lot of these times these targets, at least recently, have dropped. So our goal becomes twofold. Not only were we not able to achieve the current targets, but our future targets are also getting harder and harder to achieve. So that is one of the challenges that we face as an air quality agency. So again, some of the effects that we see because of the air quality, and they're not unfounded, because it may cause premature death, there's increased hospital admissions, and there's a whole host of respiratory effects that are associated with air pollution. So just to kind of look at the air quality issue, this is with respect to ozone. You can see the graph, it shows a time-series profile of how concentrations of ozone are developed within the basin over time. So a lot of the pollution is created actually over on the west side, so that's actually to your right of the graph. So we have a lot of the ports, we have the freeways, we have industry, so all of that's directly polluting into the atmosphere. Typically, the meteorological conditions blow the pollution from west to east. So from your screen, it's going to go from right to left. And essentially, you have a lot of chemical reactions that happen, and especially in the case of ozone. Ozone isn't actually directly emitted. There's very few sources of direct ozone emissions. I mean, one of them you have in your office is the photocopier machine. Another source of direct ozone is lightning. But the rest of the ozone that's created through photochemical reactions from the pollutants that are emitted. So it does take time, which is why you generally don't see ozone pollution over near the coast, because it takes time for that chemical reaction to occur, and it develops over on, mostly over the Inland Empire. So there is good news in this, in terms of the air quality trends for ozone have been decreasing. So our monitoring network has been measuring ozone for a long period of time in the basin. So those trends have been decreasing as we worked with the facilities, as also our sister agencies such as ARB. They implement measures to reduce the amount of air pollution from mobile sources. So a lot of that has worked towards trying to achieve those standards. And the graph here shows our trends in blue and red relative to the different standards, and the bars, straight bars across, show the standards. So you can see as we approach the more current times, we're getting closer to those goals. So this graph, think of it as a contour map. So again, as I mentioned, ozone is a creation of a chemical process, and it's a chemical process of the NOx emissions, which are shown on the vertical axis, and volatile organic compounds, which are on the x-axis. So if you think of this as a contour map, where the numbers in the middle with the lines are basically contours or gradients, and the numbers represent the amount of ozone, 80 in the orange, 75 as you approach yellow, which is getting closer to the standard. What that blue line with the arrow pointing down is kind of the pathway that is the most efficient way to achieve lower ozone. So the two strategies are, do we decrease the amount of NOx emissions, or do we focus on the VOC emissions? since the pathway shows that the fastest path is by going vertically, it means that we need to focus on our NOx strategy. So if we reduce the amount of NOx emissions, leads towards better contributions in reducing the amount of ozone that's in the air. So because of that, we want to look at the NOx emissions, or NO and NO2. So a lot of the sources for NO and NO2 are mobile sources. They're the diesel vehicles, they're the normal light-duty vehicles, so they directly emit these compounds, as shown in red and shown in pink. So there's other sources of pollution that also contribute to that, as shown in the bar graphs. The lines that go across are, again, those target goals in order to achieve the ozone standards. And the bars in the middle indicate what the predicted and actual concentrate or inventories are within the basin, given the current planning and rules in place. So you can see that we need additional measures in order for us to achieve those goals. And then when we're looking kind of in that farther future of 2032, this is kind of the predicted distribution of those sources of NO and NO2. So a lot of sources are still going to be the heavy-duty vehicles, and also, again, I mentioned the port. I think probably in the news you may have heard that the ports are doing a lot of efforts to clean up. We've been working with them to electrify kind of their shore power so they don't have to run their engines. We've asked them to change their fuel makeup, similar to how ARB did with the cars, to reduce air pollution. They are also changing the fuel type that they're using in order to reduce the amount of pollution that's entering our basin. So switching from kind of ozone to particulate matter. Again, particulate matter is kind of these particles that are in the air. The two that we're looking for are PM10, which is particles that are 10 microns in size. So that picture on the top left is basically the human hair. So 10 microns is about the size of that. And we're also looking at PM2.5, which is particles that are 4 times as small. So when we're looking at the goals for PM2.5, again, the standards are the two horizontal lines going across the chart, and the dots show the annual average concentrations of PM2.5 in the basin as we move forward in time. And again, the good news is we're getting closer and closer to achieving those targets. The standard was just revised again with new health information to go a little bit more stricter, but I mean, at least the good news is that we're trending in the right direction. So to better understand, again, the types of pollution and what we need to focus on, we do the measurements, those filters that I mentioned earlier that we take back to the laboratory for analysis. Well, that analysis produces the data which allows us to kind of split things up into different categories. And when we look at those categories, it gives information for us on the different types, because the automobile exhaust and diesel exhaust and power generation facility exhaust, they're all different chemical makeups. So kind of understanding the different chemicals allows us to identify how much of each of those sources is contributing to PM2.5 in the basin. So again, that's why it's important for us to look at this and then develop rules in order to address those particular sources. So again, kind of going back to John's example of trying to have certain targets for greenhouse gases, this other information also can help us kind of develop what sources of greenhouse gases could be emitting more, and we can maybe focus on that if those type of rules come into existence. Switching gears to air toxics, we do periodic air toxic studies called the multiple air toxic exposure studies, and we look at a whole host of chemical components. We have 10 air monitoring stations that do a full profile of chemical analysis, and they are brought back to do a health assessment based upon that data. And the good news, again, which is good for our toxics, is that between 2005, which is when our third installment of the program occurred, and 2012, when our next installment came, the amount of air toxics within the basin had declined about 50%. So a lot of the major results indicated that still air toxics, proportion-wise, the mobile sources such as diesel trucks dominate the contribution to air toxics. I mean, about 90% for diesel trucks. So when you're looking at the basin, I'm just going to kind of walk up here. This map shows the basin, and this is kind of the port area. So the deep purple indicates the concentrations that are the highest as far as the health risk is concerned. And then you can see that the most of the higher risk numbers are following the freeways and also are near the port. So that's kind of what we would expect, that a lot of the air toxins is driven again from that transportation traffic in the ports. So a lot of the measurements and modeling that we've done confirmed that. And this was the work that was done in 2004. Fast forward to 2012, and you can see that the patterns are about the same, but the levels are significantly reduced. So again, that is pretty good news. So now as we go from the air measurements, I kind of want to talk to kind of the future and where things are going. Thank you. Where things are going as far as low-cost air quality sensors. Because, you know, as you saw, we had 40 air monitoring stations to cover 10,000 square miles. You know, that is not, you know, that gives kind of that regional-wide distribution, but there's a lot of people who want to know what air pollution is at their house, in their neighborhood. So, you know, these air monitoring stations, they cost a lot of money to install. They take a lot of manpower to operate and report data appropriately. So there's been an emerging market for these low-cost sensors to be able to have more data that's more relevant to neighborhoods and more relevant to a personal life. And again, that can provide, especially since a lot of these low-cost sensors are trying to network all that data together, again, that next step to that data revolution. So the hard part about this emerging technology is that there isn't kind of an objective standard by which all of these monitors are being held to. So AQMD has initiated its Air Quality Sensor Performance Evaluation Center, or AQSPEC for short, to evaluate and essentially provide a consumer products for all these low-cost sensors. So if you want to go out and buy an air quality sensor, you can go to our site and it will show kind of an objective evaluation of those, so that way you know kind of what you're buying and what the limits, potential limits are for that particular sensor. So what we do is we take these sensors and we take them to the field to do some testing. The best performing of those field tested sensors then get brought back to our laboratory where we have a chamber, which then could do a more rigid test of the technical specifications for those sensors. From there, we can then post the results onto different categories. Some that say, well, this is maybe good for educational purposes. This is good for probably making a decision whether you want to go jogging or not tonight. And these sensors are actually pretty good that, if cited correctly, they could actually provide information that's near equivalent to what we would have at our monitoring stations. So that's kind of what we would be doing as part of this program. And all those results would then be posted on the web and into kind of a data clearinghouse of those results. And then also we take input from the community, kind of getting an idea what the community is expecting from these sensors, and then also working with the vendors to say, hey, these are things that you can improve to make it more accessible and more understandable to the public. So, you know, again, this is kind of showing the field testing. We take them out to their monitoring stations. We have, you know, these chambers, which the sensors are put close together, so they should be essentially reading all the same. They're compared against traditional methods, kind of the higher cost, what we would use for analyzing those particular pollutants. So they're ground truth to some reference standard. And then here's a picture of our lab and chamber. This was just installed in mid last year. So in there, they can fit where we have a whole host of instruments that the sensors can be compared to, and then again reported on the website. We are also testing the real-world application of them, because a lot of these sensors aren't really out-of-the-box consumer-ready. Some of them are just like a sensor with some wires on it, and that's not necessarily useful for the public. So, you know, we do a lot of the real-world testing too, because, you know, once a person buys it, there's the expectation that you deploy it somewhere and you're just going to receive data and it's going to be good. So we want to make sure that's true. So we are doing field tests to say in certain cities and also in certain practical applications, such as certain facilities, to be able to deploy these sensors and see if we can actually get certain compliance data coming from these facilities. So I mean, that's something that's emerging and we're excited about. Now, kind of connecting that remote sensing aspect. So a lot of these monitors and stations require the air to come to the station. And as Josh spoke about earlier with kind of the satellite measurements and the tower measurements, you can get an idea of what the air concentration levels are away from you, which is fantastic when you're looking at facilities, when you're looking at other areas that you can't get access to. So remote sensing becomes huge for us to be able to develop some of those technologies and implement them for air quality purposes. So, this research has been going on for decades. JPL and other agencies have been on the forefront of that. We've been working with a lot of these different organizations. So a lot of the technologies are really applicable for what we're doing. And we've developed some pilot programs to go ahead and test around facilities. This particular one is called solar occultation flux measurements. And what they did is, this is a refinery. And what they did is they drove around the streets of the refinery, and the bars right here represent the concentrations of these volatile organic compounds that it was reading in a vertical way. So essentially, it's looking at the concentration of gases as they flow from the perimeter. So the wind's blowing this way. So you can see as the wind was blowing this way, we saw higher concentrations of those organic compounds than we did see upwind, which means that the facility had some emissions that are quantifiable by this technique. And this is important for us because, before, a lot of the emissions are reported by the facility themselves, and with the measurements, again, ground truths those estimates. So what we found is the self-reported estimates were substantially lower than what we would measure. So we're now, trying to work to see, those corrections to get, again, that better estimation of what the true emissions are. So again, we want to know what our air quality challenge is, and then also too, if they're reporting less than what they should, then we go on site. We have a compliance team with inspectors that go and inspect the facilities and also address their emission issues. So some of the future projects, kind of applying what Josh had talked about with tower measurements, he was doing it in the Amazon forest. We're thinking about doing it over facilities. So doing some test cases where we can have these kind of tower measurements that are centered around the facility. Satellite measurements still aren't quite there yet to get to facility level, but these tower measurements get us to exactly what that particular facility would be emitting for these certain compounds. And again, this can be applied for criteria air pollutants, but in the future, if greenhouse gases become one of the things that need to be tracked by individual sources, this technology can definitely be applied towards that. So let's move into kind of the theme of the conference, which is climate change and impacts to Southern California specifically. So this one slide kind of talks about everything that Josh talked about rolled up into, greenhouse gases do have an impact on air quality. The graph on the top left shows that there's a correlation between increasing temperature and also the increasing concentrations of ozone. Again, ozone is part of a chemical reaction, and temperature plays into the amount of energy that can go into that reaction, so more ozone can be formed with more energy. So couple that with the temperature data that was released by NOAA in terms of looking at temperature anomalies over time. And those temperature anomalies over time show that recently those are in the positive direction. And in 2015, it had one of the highest positive temperature anomalies on record. So again, that's contributing towards an air quality issue. And as Josh mentioned, you have other implications as far as ecosystem. So, with the increased temperatures, the sea level rise, you have reduced rainfall of snowpack, which affects us because that means that there's a higher likelihood of wildfires and also the severity of wildfires. Part of my role for AQMD is also responding to large wildfires. We deploy monitors to see how much particulate matter is being released into the communities. So overall, if we have more wildfires, that again contributes to the amount of particulate matter that we're breathing. So there is direct relationships between climate change and air quality. So talking about those California targets, so this is again in the spirit of what was going on in Paris that John talked about. There's a Global Warming Solutions Act, and that is essentially gets the greenhouse gas emissions to the 1990 levels by 2020. The second one is by executive order to get everything as far as greenhouse gas emissions, 80% reduction by 2050. So those are pretty steep. Those are pretty steep targets, and again, that was directly correlated to what was discussed in Paris. So those targets are listed here in the graph. So this is greenhouse gas emissions. Again, this is the 2020 target is listed here. That's a midterm target for 2030, and then that's the final target for 2050. And NO and NO2 are also considered greenhouse gases. So again, as we reduce as far as our air quality goals, kind of connecting our air quality goals to greenhouse gases, since we're also trying to do a steep decline on that, it also helps reduce our climate change impact. So we have other policies and regulations to help reduce greenhouse gases. There's cap and trade program that was talked about, and that's being implemented by the state, along with the renewable portfolio standards. These are requirements for energy producing facilities to implement renewables as part of their energy portfolio. There's an energy storage mandate, and then movement to go to zero emissions vehicles. Again, that's reducing our dependence on fossil fuels, which reduces the carbon footprint within the basin. Giving an idea of what the different distribution of greenhouse gases are for the state, you can see still, and why we focus on transportation, is that the largest section is in the transportation sector. So if we focus on transportation, we can get a decent share of reductions in greenhouse gases. And then a lot of the other aspects are industrial and the electric generation. Again, that's why going to the measurements, we're potentially looking at facilities if greenhouse gas tracking were to be implemented as part of different rules. So I talked earlier about the increasing portfolio for renewable energies. So these are kind of the targets. So this is the current status in 2010 at 20%, and in 2020 they're trying to go to 33%, and by 2030 it's go 50%. These markers here indicate the current status of where some of those energy portfolios are. So the good news is we're on target, at least for the power companies. So if they can kind of keep going along with that trend, then they will go ahead and meet those goals. So kind of now wrapping this up in terms of measurements to climate change, there's no, as Rudy mentioned, you almost can't get any more perfect timing. I mean, it's definitely an unfortunate event, but it wraps up together as far as greenhouse gas measurements and kind of putting in context of how we move forward in the future. So as many of you know, the Aliso Canyon Natural Gas Storage Facility, it's the largest natural gas reservoir that's located just actually down that way. And there was a leak, and it was by means no small leak. And there was a lot of effort to address the leak, to understand what the impacts were, and also the impacts both on the greenhouse gas emissions, but also for our part, the communities. So we at South Coast deployed a lot of air monitoring to there. In fact, we have 3 fixed monitoring stations that we deployed there with the cooperation of the school districts and also some of the communities. They allowed us on site. And we also worked with the state to conduct measurements. Early in November, we supported a combined effort with the state and also JPL to do aircraft measurements, satellite measurements, and we were kind of doing the ground truthing for that. So it was really neat to be part of that effort to kind of look at what the initial state of the leak was so they can kind of get that estimate of, well, what kind of impact could this potentially have? So this graph shows a time series of our air monitoring stations, and this also includes ARBs. Let's see if I can get to work. So, but the dots represent on the map, and I should point out that the leak occurred right here, and these are the nearest streets in the community that we had deployed our air monitoring stations. So these are the concentrations of methane over time. So it's an hourly profile of how the concentrations change. As the dots go from blue to red, the concentrations are higher. But you can see that most of the time the concentrations are what we'd expect typical, between kind of that 0 and 3 ppm. But there are times, a lot of times during the night, that the concentrations would go really, really high up to hourly average of 50 ppm. And that's 20 times beyond background. So when kind of taking those results as a whole, these were the concentrations that were monthly average of January for all the different sites. So those are all the sites between ARB and AQMD. And I wanted to focus your attention on the sites that are closest, which are these. And you can see that nearest the facility, the average methane concentrations were the highest. And right before the leak, which is the blue bar, it was actually higher than the monthly average of January. But when we looked at the methane averages after the leak was considered sealed by the Dogger Agency, you can see that the amount of average methane had declined. ARB was also conducting airplane measurements to estimate the amount of methane that was being released as part of the leak event. And this is kind of just a weekly profile of the emissions. And the leak was initiated to be sealed February 10th. So you can see the dramatic drop in the emissions from that. The red line indicates the total amount of methane that was released, so cumulative total starting from day one of what methane has been released. And they estimate that this increased the state's greenhouse gas contribution by 18%, just this one leak alone. What we did also was to get you saw that we had these fixed stations. We had a mobile platform that went out just to make sure that methane didn't shoot over the community and hit other areas that were farther away. So we had this mobile platform which has a sensor up on top. It's called Open Path Liquor Unit. So we drove around the different communities from the lake here, just about 8 miles between here and here, just to get an idea of and to make sure that methane wasn't observed farther away. And this is a zoom in of the Puerto Ranch area, and you can see that we, as we expect, see higher concentrations of methane closest to the leak. Lastly, just from an air toxics perspective, it is one thing to be measuring for methane, which is the indicator for natural gas, and of course is the one of the greenhouse gases. But also from the air toxics perspective, we measured benzene, which was a compound of concern, and we did basically samples to come back to the laboratory and compare them against the MATE study that I talked to earlier, our air toxic study. And it showed that on the MATE study, right here, this is the average for the entire basin, and the average was about 0.4. We had collected samples very similarly, same methods, and you can see that at least for benzene, the concentrations were what we would consider within typical concentrations. And the 2 bars here represent the 2 air monitoring stations for the MATE study that were closest to Puerto Ranch and Aliso Canyon. So, for us, at least for certain compounds of concern, we feel that, they were typical, but obviously for like methane and other things, they were a lot higher. With that, I can take questions because I know my time's up.
Peter.
I think it is a very information-packed presentation.
Yeah, sorry.
On the last point about the Puerto Ranch 18% contribution to the state greenhouse gas emissions, is that per year or what?
That would be for 2015, at least according to ARB.
Okay, so that is something like what we're aiming the state as a whole to have by 2050 then under the executive order. That one leak is most of the budget.
Well, I mean, yeah, when you're considering California as a budget, because again, that's California, not necessarily the nation. But yeah, if you're taking part of the goals as far as greenhouse gases is concerned, I mean, it just shows how fragile the emissions budget can be with an event like this, which is why more concern is being applied towards it.
Is there enough understanding of what caused that leak? Perhaps that leads to some reassessment of all these predictions for greenhouse gas reduction targets in terms of the mix of methane as we switch over from other fuels, and methane's an important part of the transition that's happening right now. So are there some lessons learned that are being propagated out to both in terms of predictions and in terms of how these natural gas storage facilities are handled?
Sure. So I think the question is, are there any impacts or lessons learned from the leak that would help us, I guess, twofold. One, address kind of natural gas reservoirs in general, and then number two, give a better of kind of maybe greenhouse gas emissions period. So to the first question, yes, there's a huge reassessment going on. In fact, right now, the state agency that's responsible for looking at wells and how they're developed and built and operated, that's the Department of Geophysical, Geothermal Resources, or DOGGR. So they're doing a root cause analysis of what exactly occurred, how this leak occurred, and from that information, I believe ARB is also looking into rule development to learn from that report and kind of what went on to, number one, probably increase inspections. In fact, South Coast has an order of abatement with SoCal Gas that is consistent with, that we worked with Dogger to develop as far as, enhance well inspections. So again, get that assessment, but then from that root cause analysis, take the lessons learned from that and perhaps include that into rulemaking. So I think that's kind of the current paradigm. And I know the state and also South Coast and Dogger, they're all looking at what potentially each agency can do in their roles to affect that change.
Okay, so you said that you did measurements within the local community and around 8 miles away from the local community to see if methane actually affected the populations in that area, right?
So let me start off with methane, at least according to health experts, does not have an air toxic property to it. So methane we were using as an indicator for the natural gas exposure. So because the major component of natural gas is methane, the elevated presence of methane, because there's typically not that many sources and the kind of natural background is pretty well known for methane, that if we see levels that are higher, then it's a good indicator that there's a nearby source. And there's other components that we can look at to confirm whether it came from the facility or not, but we do our best on the chemical nature to show how much was inside the communities at that time.
All right, so how does wind blow affect the travel of methane?
I'm sorry, could you repeat that?
How much does the wind affect the travel of methane?
So wind is a huge component of how much methane is being blown into the community, or how much methane is being, I guess, how much the community is being exposed to methane or the natural gas.
Right.
So as I mentioned earlier, the typical meteorology is that the wind blows from the west to the east. However, when you're in a canyon setting, there's what's called canyon drainage that occurs at night. Essentially, the temperature is cool, and basically the gases that are up there get compressed and follow along the canyons. So a lot of the homes that are kind of in that area and that are neighboring the facility are at the bottom of some of these canyons. So what you would see is a lot of times that time series showed, a lot of times you'll see the enhanced concentrations of methane at nighttime.
All right. And so over time, then what happens to the methane? I guess it didn't blow out our direction, but then what does it do? It just go straight up and blend out into the overall air atmosphere?
Right.
Higher?
So anything kind of below at the lower atmosphere is considered turbulent, so it's pretty well mixed. So over time, essentially, it will go out into the atmosphere and get diluted and distributed across the larger world. Methane is fairly long-lived. So the molecules of methane will live long enough, quote unquote, to see the world. There are other components that are short-lived, so they react really fast. So they only travel maybe only 5 hours before they get reacted away. But methane, because it's not very reactive, it can get distributed in a larger radius.
Okay, so are you saying basically that the fact that the leak was in a canyon pretty much saved communities like ours from being exposed to it? And then what happens, well, if a leak comes out in other areas that are not in a canyon, that's when we ourselves would be in more danger.
Right. Well, again, like I said, methane itself doesn't have air toxic properties, but I mean, when the winds were blowing kind of the normal daytime, the amount of, I guess, available volume of air, allows methane to mix a little bit more. I mean, you may still see it because, working with JPL, working with, they have some initiatives and tower measurements over the basin. They were able to see some methane being distributed at the higher levels. So it's not necessarily methane that maybe was exposed at the surface level, but again, that plume went up, it gets turbulently mixed, so you can have an enhanced methane signature as part of that in a higher level than we can breathe.
Okay, thank you.
Hi, I'd like to go back to the greenhouse gas pie chart. I was just wondering how you determined what gets included in the pie chart.
Okay, so this is the pie chart. I think this was done by ARB, so I can't speak to how it was exactly developed. But a lot of times what they're looking at is emissions inventories when they develop pie charts like this, if I'm speaking kind of like stationary sources. So they can get certain estimates from certain databases. And from that data, they can convert everything to essentially a CO2 standard. So there's different gases that have different global warming potentials. So like methane. Methane is a much higher greenhouse gas potential than CO2, so they just convert it to one common metric. So they take all the sources of what are considered greenhouse gases, they have to do a conversion of that to that common unit of million metric tons of CO2, and based upon where the sources of all those different gases are, they can then apportion it to the different categories.
All right, I just bring it up because the film Cowspiracy would suggest that the meats industry is a significant contributor, and I don't think it's included in the pie chart, so just wanted to.
Okay, which
bring it
industry?
up. The meats industry.
Okay. Yeah, if it's agriculture, agriculture is represented on the chart. Yeah, it's 8% on the chart.
I'm not sure if I can articulate this correctly, and I'm not sure that you can answer it, but I'll try.
Okay. And I'll try too.
So it's fascinating to see how this works, and I really, really appreciate the work that your department does. I can see that it's standard-based, it's regulation-based, which is what California seems to have done, not market-based. And so my interest is how much of this conversion toward meeting the standards is, in your opinion, market-based? Like if you add up price, then industry changes itself. Like we don't tax copy machines for the ozone that they emit. So that would be a market-based, in my understanding. So in your understanding, how much is the market involved in meeting standards?
So there is a cap and trade program, which is essentially, at least, I'm not necessarily an expert with greenhouse gases, but at least with air quality within the basin, we have a reclaim program, which is a cap and trade system, which is based upon market incentives. So those market incentives can be brokered just like stocks in a way. There's a certain value assigned to pollution. You can get pollution credits. Those are sold on the open market as well as traded between organizations. So in case there's a facility that would be emitting a lot more than they should, then they have to try to buy up credits essentially from somewhere else or from a reserve. So there is market incentives for certain things.
And you think that that's working well?
I think that's a subjective question. So. Let
me wrap up here. Yeah, what a fabulous morning, and I want to thank all three of our speakers. I'd like to. And I'd like to thank Neighborhood Church and our 8 other co-sponsors and the ones who had tables out here. That was very nice. I'd also like to thank the League of Women Voters Natural Resources Committee, who were enormous help in putting this whole thing together. We had a lot of work there.